All right, so what's the difference here? I have two frames. I'm going to go kind of quickly here. I'll probably pause it while I do my writing. But what I want to just show you here is that these frames look very much the same. Now they're not going to have the same answer because this one's in pounds, this one's in kilonewtons. I just want you to look at the shape. Obviously, the shape is going to be pretty much the same. However, this has got a pin and another pin and another pin. Now, if this was a fixed bar, we would say this is improperly constrained because it'd have to have a pin and roller if this was fixed. However, if this is a pin, it is now a frame, so it's now looking more like a truss, except that trusses don't have forces applied in the middle. So this is a legal frame, and we can analyze it, trying to find out what the external reactions are. Over here, this one is a fixed support, so this is going to be quite a bit different. Let's just start with drawing our unknowns so we just know, or drawing our reactions so we know just a little bit about what we're up to. I'm going to say that there's going to be an AY and an AX over here, CY and CX. So I have four unknowns. I only have three equations of equilibrium. I can recognize perhaps that this is a two-force member, and if I do that, then I could solve it without breaking it apart. But I'm going to keep it. I'm going to break it apart when I solve this for you. Let's look at the unknowns over here. I have this AY, AX, and at D I have a DY, a DX, and because this is a fixed support, I also have a moment reaction, a moment about D. That gives me five unknowns, and clearly I can't solve that with our current or without breaking it apart. So let's go ahead and solve this one here, and let's see what we can come up with. What I'm going to do is draw. Again, what I'm looking for is the external reactions. I'm going to draw two free body diagrams and see what we can do. Okay, so I have drawn the free body diagrams, separated this out, right like this. I have a reaction here, AX and AY. And I know that because this is a pin, it has a BX and a BY. Over here on this one, it is pin connected at both sides. I have a 400 going down, a 500 going down, and two pins. So let's look first at B. If I draw BX there, that way on this part, has to go that way on that part. BY has to be equal opposite. CY and CX, I don't know for sure, but they're consistent with what I've drawn here. If I drew BY here, I'm probably going to need a BY or CY that way. If BX is positive that way, it's probably going to be positive in that direction. What we're looking for is the directions of the components. So let's understand our two-force rules here. I'm going to say that this is a two-force member. It's pretty easy to see here, and we know that AX is equal to BX and AY is equal to BY. Those are just rules, and let's see what we can come up with. I don't have anything I can solve for sure here yet, so what I want to do is start over here on this side. So I got a 400 and a 500. So let's sum the moments about C. Sum of the moments about C is equal to 0. I got BY times 9. And that's going in the negative direction. I got 400 times 6 plus 500 times 3 equals 0. So I can solve that for BY is equal to 433, 3.3 pounds. Okay, can I solve anything else? I actually could solve for the forces in the y right here. So let's go to do that. Sum of the forces in the y is equal to 0. So I got BY plus CY minus 500 minus 400 is equal to 0. So CY is equal to 466.7. Okay, then I got two of the components there. what can I do? Let's take this and put it over here on this other side. I know you didn't see me waving my arms here, but this means something from the right side and put it on the left side. So I'm going to sum the moments about A over here. It's kind of sloppy. Sum the moments about A. Okay, here I got minus by times 3 plus bx times 4 is equal to 0. If I've got a by here, I can plug that into there and solve this for bx is equal to 325 pounds. Once I have bx, I can find ax and ay. And I've already got by, so I can just write by observation. bx, or ax, is equal to 325, and ay is equal to 433.3. So those are two of the pieces of the components I was looking for. Once I find bx, I can plug that back in over here and do some of the forces in the x. And just looking at this equation quick, or this situation, once I have bx, I should be able to solve cx. And cx is equal to 325. So that's kind of how you do it. You solve part of it. You have to walk back and forth between the two free body diagrams. When you do this and solve this on an exam, I really like to see these arrows because that really helps me understand your thought process. So if you find something on one side and you have to go over to the other side, draw a little arrow like that. Then if you find something here that you have to go back over here, draw another arrow. That really helps me understand your communication. All right, the next thing, or the last thing I want to just visit with you about is this fixed support. We haven't done a lot of fixed supports other than just those Chapter 5 problems, but we're going to do more as we go through in frames here and a lot more in Chapter 7. So let's see what we've got. We've got a situation here and here. We have 3 components of reaction here. I'm just going to zoom in here and show you how to solve this thing. I'm going to zoom in and show you how to solve this thing kind of quickly, but draw 3 free body diagrams. Now, where do you start? Again, there's probably, you don't know any of the you don't know anything here, and there's too many unknowns here with this. So I would start in the middle. I would start here. The reason is because here I can actually come up with some answer. Because this is lined up here, if I sum the moments about here, I can find by. Sum the forces in the y, I can find cy. And now I can then move here and probably go from here over to here. From here I can go to this side and recognize that AY and BY are going to be together. Now you can look at this two-force member, get some rules here. You know that AX is equal to BX. Plug AX and BX back into here for this equation and find out what CX. Now that we know CY, let me go ahead and put a box around CX. Once I know CX and BX, or sorry, CY and CX, then I have something I can solve over here for this reactions. So once I know CX, I should be able to find that moment. Once I know that moment, once I know CX, I can sum the forces in the X is equal to 0, sum of the forces in the Y is equal to 0, and you can get all the components right there. So it's actually fairly complicated, but what you need to do, or what you should remember, is break it up into 3 free body diagrams. And again, you might have to go back and forth a couple times in order to get these things resolved.